So welcome back, guys. Welcome back, and let's do this very basic, easy probability problem. So this problem may help you revise the concepts of basic, a conditional probability. So let's get started, and also the axioms of probability too. Um, so if you observe this problem, you will find out that there is like a similarity, because like probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, this is called the principle of inclusion and exclusion. So it's just a conditional event has been put up. Okay, so is this true or not? So that's the question, if is this is true or not. And is it true or not? Is it true or not? So that's the question. So what do you think? Of course this is true due to the following reason. So let me prove it. First of all, conditional event is sort of, it's just probability of any event if given C is nothing but probability of F intersection C by probability of C. Okay, so and we know that that corresponding event happens, that probability of A intersection B is equal, sorry, A union B is equal to probability of A plus probability of B minus probability of A intersection B. We all know that, right? We all know this is true. And if we know this is true, then how we can come to that conclusion logically? How we can come to that conclusion logically? So we can understand that if this is true, then so some result is true, and then what we do is that we intersect each one of them with another C. So that is, you're restricting. So let's say what this means is that if there are two events, A union B is equal to A plus B minus A intersection B. Okay, so what you do is that you intersect with C. That means, let's say C is this. Okay, so now A and B change, right? A and B changes to this. Let's see how A and B changes. A and B change. A changes to this, just this, and B changes to the other one. Let's draw it. B changes to this one, right? B changes to this one. So like if we take the intersection, so A goes to A intersection C and B goes to B intersection C. Okay. Now if we call it A dash and B dash, here also A dash union B dash is का probability is equal to probability of A dash plus probability of B dash minus probability of A dash intersection B dash. Okay, and we can easily show this that A, so we can write this as probability of A intersection C union B intersection C, okay, is equal to probability of A intersection C plus probability of B intersection C minus probability of A union C intersection B intersection C. Just replacing the values over here. And we can easily tell it from here that it's same as. You can easily tell it from here. It's nothing but it's same as. You can intuitively tell that it's same as what? All of these elements is same as that. It's telling its whole intersection. Why? Because A union B intersection C is the same thing. We're just intersecting the C. That's it, right? We take this as an element and we intersect the C. That's it. That's the basic idea. And similarly here it's also intersection that is really observed from this, and here also it's same. A intersection C intersection C, A intersection B intersection C, because of the commutative and distributive property of the behavior of the set functions, binary set operations like union and intersection. So it's really beautiful, and we get this final form. What form we get? We get that probability of, oops, let me just fit. And yeah, so what we get? We get probability of A intersection B intersection C is equal to sorry, A union B intersection C is equal to probability of A intersection C plus probability of B intersection C minus probability of A intersection B intersection C. Okay, now if you observe, if you divide by probability of C, okay, if you divide by probability of C, if you divide the probability of C, what you will get? You will exactly get the above one, just the above equation by the property, by the definition of conditional probability. And it's a really easy problem to work out, and it's really important and idea to see how the condition, like given C means that you're restricting the sample space to C, like you're restricting the space to C, and the same behavior actually happens. Okay, no behavior changes, and it's all good events means that not all good events ke upar we can apply probability. So good events means in some sense measurable sets, but that's not a thing that we're interested in. We are interested in this behavior conditional probability. I hope you liked it, and it will be a true one. I hope you enjoyed it, and that's it. That's the solution from my end. And if you have any other ideas how we can do it better, any different views, any different way of thinking, or if you have done any mistake over here, you think, so please do comment down below, and let's discover and learn together. That's the only purpose of Cheenta School of Statistics and Data Science. So all the best, guys, and I will see you in the next video. Till then, stay tuned and stay blessed. And if you're looking for some CMI Data Science crash courses or mock test series, do check the links below of our preparation. All the best, guys, and I see you in the next video. Stay tuned and stay blessed. Yeah, and don't forget to subscribe and share with your friends who are really preparing with their own. All the best, guys.